Today's seminar is going to focus on writing and graphing linear equations in standard form. The goal or I can statement for our lesson is I can write and graph linear equations in standard form. So at this time I'd pause the video and write this heading as well as the goal in the top of your notebook. So we're going to have two different foldables today. One of your foldables is going to look like this, writing linear equations in standard form. So we'll be looking at what is standard form. We'll be looking at writing equations in standard form as well as graphing equations in standard form. We'll also be taking a look at a second way to work with equations in standard form, and that's using x and y intercepts in order to graph the line. So you'll need both of these. And we'll start with the writing linear equations in standard form. So this one here. Alright, so as you know, we've been working with linear equations, especially slope-intercept form and point-slope form, but there is a third version of an equation for a line, and that's known as standard form. So what standard form is, it is ax plus by equals c, where a must be a whole number, and for our purposes we're always going to make a positive. It doesn't have to be, but for keeping things uniform and having one answer to look for, we're going to keep this a positive. And then b and c must be integers. Now remember, integers are numbers that can be represented as fractions. So you'll see what we mean as we continue to work through working with standard form, which again is ax plus by equals c. So let's take a look down here at example 1, and let's do some transformations here. So a couple different things we're going to be asked to do in this case is we're going to change from slope-intercept form, as you can see here, y equals mx plus b, so you have your slope and your y-intercept. And we'll also be working with point-slope form and changing that to the ax plus by equals c form. So let's go ahead and start with problem A here in example 1. So our goal is to get x and y on one side with a coefficient of a and b, and then we want to just leave anything that's not associated with x or y over here as c, which will end up being really our y-intercept. So again, we're going to have to solve equations here. We'll be doing 1- and 2-step equations specifically. Now with this problem here, we need a to be a whole number, and the number that's next to x currently is a fraction. So I want to get rid of that. So what I'm going to do, in order to get rid of that, I'm going to multiply both sides of this equation by 4. And we'll have to use the distributive property on the right-hand side to do so. So 4 times y on the left-hand side is 4y equals, if I do 1/4 times 4, I am going to get 1. So I just have x. And then what I'd have here is negative 3 times property here, remember again, to the coefficients and the whole number. So x, negative 3 times 4 is negative 12. Now we're not quite done here because right now we just have a different version of slope-intercept form. We need to get, so x and y need to be on the left-hand side. They could be on the right-hand side, but let's just keep it on the left in order to keep things understandable here. So I'm going to need to move this x over to this left-hand side. So how do we do that? Well, this is a positive 1 in front of here, so that means I need to subtract x. Subtract x. Now we can't add or subtract 4y and x, so we just need to rewrite them so they're both on this side. So I would have negative x plus 4y equals negative 12. So again, we're just manipulating the equation and moving things around. Now we're almost there. This almost looks like ax plus by equals c, but as you recall at the beginning, I asked for the a to be positive. In this case, it's negative. So what I want to do is just divide everything by negative 1 in order to make this positive. So this whole thing, I'm going to divide by negative 1, and I'm going to divide this side by negative 1 in order to make these positive. Now remember, we're dividing the coefficients, so negative 1 divided by negative 1 would be positive 1. I just have x, or 1x, if you prefer to write it that way. Either way is fine. 4 divided by negative 1 will be negative 4, so I have minus 4y equals negative 12 divided by negative 1 would be a positive 12, and that would be my final answer. So we've taken the slope-intercept form of y equals 1/4 x minus 3, and we've changed it into standard form, this ax plus by equals c. That's what we have here. X minus 4y equals 12. So as you can see, there's a lot of stuff that we've done in the past in this problem. We have distributive property. We have solving equations, moving things around, integer operations here, negative divided by negative, positive divided by negative, negative divided by negative. These are where these skills come back into play and where we need to use them. Let's take a peek here then at letter B, where we have this written in point slope form. So we're going to have to do an extra step here by changing this back to, well, we don't necessarily have to change this back to slope-intercept form, but we do have to carry out the distributive property here first. We need to get rid of this parenthesis. So that's what I'm going to do first. I'm going to distribute this 3 to the 1 in front of this x, as well as this 2. So I'm going to rewrite what's on the left-hand side. Y minus 4 equals 3 times 1 is 3, and the x would come with, so 3x. 3 times 2 is 6, so we have plus 6. Now remember, our goal is to get this to look like ax plus by equals c. We're transforming to standard form. So we're almost there. I see a problem here with this negative 4 and the 3x. I want the 3x over here and the 4 over here. So we're going to have basically a two-step equation here, and maybe a 3. So first and foremost, I'm going to get rid of this 4 here. So in order to undo that, I want to say plus 4. And if you want to drop your line in here, that's fine. That'll work. And remember, combining like terms, here's another thing we've done. This 4 needs to get added to this 6. So let's rewrite what we have. These cancel. Y equals 3x plus 10. So we're almost there. We need to just bring this 3x to this side here so that we are looking like this form here, ax plus by equals c. So what I need to do then is subtract 3x, subtract 3x. Remember, we can't combine this y and this x because they're not like terms. So I'm just going to rewrite this with my x term first. Negative 3x plus y equals 10. Now this is a correct version of this, but I want to have the coefficient in front of the x positive. So I'm going to do like I did over here in example A and divide by negative 1 on both sides. And I'll write this answer up top here because we ran out of room. So negative 3 divided by negative 1 would be a positive 3, so I'd have 3x. There's a 1 in front of this y. So 1 divided by negative 1 would be negative 1. So we'll say minus y, and 10 divided by negative 1 is a negative 10. So our final answer in this case is 3x minus y equals negative 10. This form, and actually this here, which is slope-intercept form, all represent the same line. We just use standard form in certain occasions, like systems of equations sometimes, which we'll be getting into in the future here. So this is what we need to do when we're transforming using algebra. If we want to go from slope-intercept form to standard form or point-slope to standard form. It's good practice to know how to manipulate each type of these equations into the different forms. So let's move forward then with writing equations in standard form given a graph. Alright, so it says here, write an equation in standard form for the line graph below. This is going to be exactly like what we were doing previously. We're just going to have an extra step involved. So from this graph, the first thing I'm going to want to do is write this in slope-intercept form. So we want to make this be y equals mx plus b, where we need to find the slope and we need to find the y-intercept. So let's find the slope first. I'm going to start with my leftmost point, which is this one here, and I'm noticing that I'm going to be moving down, so that's telling me my slope's probably going to be negative. So what it looks like is I'm going down 2 and to the right 3. So negative 2/3 is going to be my slope. So y equals negative 2/3 x, and then my y-intercept looks like it is here at -1 or 0, -1. So I'm just going to put a -1 after this then. Alright, that's half the battle. Now we want to change this to standard form. So this is in slope-intercept form right now. We want to go to standard form, which if you recall is ax plus by equals c. So it looks like we're going to have maybe one step here, well, 2, because we need to make sure that this number, this coefficient in front of x, is a whole number. Okay, we need to verify that, because if you remember here, a must be a whole number. It can't be a fraction. So the first thing that I'm going to do in this case is I'm going to add 2/3 x to both sides. Now remember, we can't combine this y and this x because they're not like terms. So if I rewrite this, I'm going to have 2/3 x plus y equals -1. It looks like we're done, but we're not. We need to get rid of this 2/3. So the best way of doing that is just to multiply by what's in the denominator of this fraction. That'll be the best way to get rid of it. So if we multiply this whole side by 3 and this side by 3, we should be in business. So if I did 3 times 2/3, I would end up with 3 times 2, which is 6. 6 divided by 3 is 2. So I'd have 2x here. And we're actually using the distributive property here. So 3 times 1 is 3, so we'd have plus 3y, and that's going to be equal to a -3. And in comparison to the form just given, for any case of standard form, ax plus by equals c, looks like we have ax plus by equals c, where a, b, and c are whole number coefficients and integers. So what I'd like you to do now, pause, try example 2, and I will go over it in a second then. Okay, so you should have given B a try. So let's just run through this real quick. So what I want to do is say, remember slope-intercept form, we want to do that. Y equals, let's find our slope and our y-intercept. So in this case, starting from the leftmost point, it looks like I'm going up, so my slope's going to be positive. I'm going up 1 and over 1, 2, 3, 4, 5. So it looks like my slope is 1/5. 1 over 5x, and my y-intercept, so that point where it crosses the axis, the y-axis. Looks like it's at 0, 3, so I'm going to have plus 3 here. So just like before, we're trying to get this into standard form, which again is ax plus by equals c. And what I'm going to need to do here is subtract this 1/5 x, because we want x and y on the left side of my equation. So let's subtract 1/5 over. Subtract 1/5 x over. We can't combine this x and y, so we're just going to separate them, saying minus 1/5 x plus y equals 3. Now there's two things that I don't like here. We're not quite done yet. For one, this is a fraction and it needs to be a whole number, and it's negative. So we could do this in two different steps, where we would first get rid of the 1/5 and then get rid of the negative, but let's just kill two birds with one stone here and multiply by a negative on both sides, because that will give us a positive number. Remember, we're going to multiply by what's in the denominator, but I'm going to make it negative so that this coefficient on x becomes positive. So minus 5, so negative 5 I'm multiplying by on both sides. So if I do negative 5 times 1/5, I'd end up with 5 over 5, or 1, so just x. If I multiply, there's a 1 here in front of this y, remember. So negative 5 times 1 would be negative 5y, and that's going to be equal to negative 15. So looking back at my standard form here, the generalized equation for that, ax plus by equals c. We have a coefficient of 1 here, so that checks out, and it looks like that form. It's okay if there's subtraction between here. That's fine. We just don't want the coefficient on the first one to be negative, although it's not wrong. Alright, so that's writing equations given a graph. Let's step it up here a little bit and move to graphing the equation given standard form. So the way that I want us to do this is changing to slope-intercept form. That's the first thing that I want us to do. That'll be the quickest for us to do as well. So we're kind of working backwards from what we did on writing. Now remember, slope-intercept form is y equals mx plus b. So really what we're doing here is we're trying to get y by itself. So we're going to end up with probably a 3-step equation. The first thing that I'm going to do is I'm going to drop my line in. I need to get rid of this 3x. This needs to come over to the right side. So let's subtract 3x and rewrite what we have. So on the left side, I'm going to have negative 6y, and that's going to be equal to, well, we can't combine 18 and negative 3x. They're not like terms. So I'm going to set this up just like the right-hand side of my slope-intercept form. The number next to x is going to come first, so that's negative 3x. And this is a positive 18, so I'm just going to add 18 here. Almost there. We need to get y by itself. And in order to do that, we need to divide by negative 6 on both sides. And we need to divide everything by negative 6. So we need to divide this by negative 6. We need to divide negative 3 by negative 6. And we need to divide 18 by negative 6. Because what we do to one side, we need to do to the other. We have to keep that balance when we're solving algebraically. So negative 6 divided by negative 6 is just going to be 1. So I just have y here. Y equals negative 3 divided by negative 6. I know it's a negative divided by a negative, so it has to be positive. This is going to be 1 over 2x. 18 divided by negative 6 is going to be negative 3, so just minus 3 here. And now we have something that we know how to graph in slope-intercept form. So let's go ahead and graph this real quick. So slope b is negative 3. I'm going to plot that on the y, because that's the y-intercept. And my slope says up 1, right 2, up 1, right 2. Throw a straight edge on here and graph this puppy. So this is a problem where you have to combine a little bit of algebra as well as graphing. So what I'd like you to do here, go ahead and pause the video and give B a try here. And I'll go through it, but definitely give it an attempt and then see if you did the same things that I did. Alright, so you should have tried this then. So remember, we want to get this in slope-intercept form, y equals mx plus b. That means I need to get y by itself. I'm solving for that. So the first thing I want to do is subtract x. Rewrite what I have. 4y equals negative 1x plus 12. Remember, you can't combine these, this 12 and this x. They're not like terms. So I'm just rewriting it so it looks like slope-intercept form. Next, I need to get rid of this 4 with this y. They're multiplied, so division undoes multiplication. Remember, divide everything by 4. So I would end up with y equals negative 1/4 x. 12 divided by 4 is 3, so plus 3. That's in slope-intercept form. We can go ahead and graph that. So this should be at 3, and we want to go down 1. 1, 2, 3, 4 to the right. I ran out of room, so I'm going to work with my slope backwards. Go up 1, and 1, 2, 3, 4 to the left instead. Grab your straight edge. Throw another line through those points. Arrows on the ends. And that completes that problem. So this is one way of graphing these lines in standard form, or using standard form, is one way is we can change from standard form to slope-intercept form and then follow our procedures for graphing a line using this. There's one other way though, and that's going to require us to use our second foldable. So we'll go over that now. What I want you to do is make sure that this foldable gets put into your notebook, as you'll need to refer to this in the future. The next one you should get out looks like, zooming in the wrong way. Zoom all the way out quick. So this is how I want you to set this up in your notebook. And when you get to this point, I want you to ask me for the stamper so I can stamp 2 graphs in your notebook, because the example that we do together, I want you to try a couple on your own. So we're going to start up in the foldable. And this is a second way of graphing lines in standard form, which might be quicker. Some of you might prefer this, but I want you to know both ways. I think it's absolutely vital that you know both of them. So let's go ahead and open this top here. First and foremost, the definition of an intercept. Now, we've been working with the y-intercept frequently here using slope-intercept form, but there is something called the x-intercept, and that's just where the line crosses the x-axis. So just a definition of an intercept is the point where the line crosses the given axis. And the given one they're referring to is either x or y. It depends what you're working on. So let's just label a couple of things here. So this here is going to be, this is your y-intercept. So let's just draw an arrow over here. And I'm just going to abbreviate it as y-int. And that's going to take the form always of 0 will always, or x will always be 0 in that case, and then you're going to have some value of y. And in this specific case, it's actually 2. So our y-intercept on here is 0, 2. Now similarly, we can have an x-intercept. That's where the line crosses the x-axis, and that's at this point here. So this, like I said, I'm going to abbreviate this as well. This is your x-intercept, that's always going to take the form of some value of x, and y will always be 0. In this case, it looks like it's 3, 0. So how we're going to work with this is with an equation in standard form, we can substitute the value of 0 in for x or y, find both x and y intercepts, and then graph it from just the intercepts, because we only need 2 points to make a line. So sometimes this is quicker than changing to slope-intercept form. So let's work down here in the bottom of our foldable then. So how do you solve for the intercepts given the equation of a line in standard form? Well, let's figure that out. So down here, we have 3x minus 4y equals 12, definitely in standard form. So what we need to do is find the x and y intercepts, and this will help us figure out what the graph looks like. So if I first want to find the x-intercept, I'm going to need to substitute 0 in for y, because if we look up here, y is always 0. So if we know those are equivalent, we can substitute that in our equation, solve for x, and boom, we have the x-intercept. So let's go ahead and do that. 3x, I'm going to copy this down, minus 4y equals 12. We're going to substitute 0 in for y because we know that value. So let's do that. 3x minus 4 times 0 equals 12. Negative 4 times 0 is 0, so that's gone. So all we have left here is 3x equals 12. Now it's just a one-step equation. We're going to undo multiplication with division. So divide by 3, divide by 3, x equals 4. Now if we set this up as a coordinate, the x-intercept would look like this. We would have 4, 0. Because we know what our y value was. We know that at the x-intercept, the y is always going to be 0. So on the flip side of that, let's look at the y-intercept. So what we're going to do is just the complete opposite. We're going to substitute 0 in for x, because if we look up here, with the y-intercept, your x point is always 0. So let's rewrite our equation. 3x minus 4y equals 12. We're going to substitute 0 in for x, because we know that's the value at the y-intercept, value of x at the y-intercept. So 3 times 0 minus 4y equals 12. 3 times 0 is just 0. It's gone. We don't even need it there. Careful here. This sign goes with this 4, so it is negative 4y equals 12. Divide by negative 4, because we're undoing that multiplication. Y equals negative 3. So if we rewrite this, we know that the x value is 0. If we're writing it as a coordinate, I should say. And y is negative 3. Now if I had the graph for this, and maybe I can do this up here, if I plot the point 4, 0, so over 4, up 0, that's our x-intercept. It should fall on the graph here, right? So that's 4, 0. And then if I do 0, negative 3, that should be exactly on the y-axis. 0, negative 3. I have those 2 points. I can just graph this line. So if I just throw that through there, all I did was find the x and y intercept instead of changing to slope-intercept form. You are going to be required to use both, but if you're given the option, like let's say in ALEKS or on a homework assignment where it says solve however you feel comfortable with, use what works for you. Both versions will work. Sometimes this is a bit more efficient. Sometimes changing to slope-intercept form is a bit more efficient. It all just depends. All right, so there's your example. What I want you to do is try the problems here below. And you should have these set up in your notebook. If you need me to come around to give you the stamper, please do so. So pause the video here, give these two a try, and then I will run through them as well. Okay, so you should have worked through these, and what you should end up getting, I will just do my work over here. So if I'm going to find the x-intercept first, I need to put 0 in for y, so 5x plus 5y equals 15. Going to rewrite my equation, that's good practice. Said we're solving for the x, so y is 0. 5x plus 5 times 0 equals 15. 5 times 0 is 0, it's gone. So I'm going to have 5x equals 15, divide by 5, divide by 5, x equals 3. So my coordinate here for my x-intercept would be 3, 0. Now similarly, you're going to have to find the y-intercept. So that means for your y-intercept, your x value is 0. So let's just plug that in. I'll do it here. 5x plus 5y equals 15. And in problems like this, I want you to show your work so I can see what's going on. So 5 times 0 plus 5y equals 15. 5 times 0 is 0. That's gone. So 5y equals 15. Divide by 5, divide by 5, y equals 3. That coordinate would end up being 0, 3. So we need to plot both of those. So over 3 up 0 here, and over 0 up 1, 2, 3. Throw a line through that using your straight edge, and you have graphed that line using the intercepts given the equation in standard form. This one over here, you should have, you'll do the same thing. So let's find the x-intercept first. 5x plus 2y equals 10. So I said let's find the x. That means we're going to put 0 in for y because we know that at the x-intercept y value is always 0. So negative 5x plus 2 times 0 equals 10. 2 times 0 is 0. So I'm going to have negative 5x equals 10. Divide by negative 5, divide by negative 5, x equals negative 2. That means the coordinate is negative 2, 0. We need to find the y-intercept yet, so rewrite my equation. Negative 5x plus 2y equals 10. We're going to have to put 0 in for x to find the y-intercept. Negative 5 times 0 plus 2y equals 10. Negative 5 times 0 is 0. 2y equals 10. Divide by 2, divide by 2, y equals 5. That coordinate would be 0, 5. Plot those. Negative 2, 0 is going to be here. 0, 5 is 1, 2, 3, 4, 5. Put the line through there. Arrows on the ends. And that's what that answer should look like. So again, both graphing and algebra are involved in these. A lot of these types of problems with standard form are algebra heavy, so it's going to be important that you understand things like distributive property, solving 1, 2, 3-step equations, your integer operations. If you don't have quite a strong hold on those, some of these things might be a little bit difficult and you might need to refresh yourselves on those skills. But other than that, make sure that you get all of your foldables into your notebook so that you can refer to them in the future. And just a reminder as to what we did today. We were working on writing and graphing linear equations in standard form. And the goal of today and the I can statement, I can write and graph linear equations in standard form. If you have any further questions, you can always watch the video again, look over your notes, and as always, I'm available for help.